I'm going to talk about cylinders. I'll assume that you know the basics of prisms, including the volume formula for prisms. I'll also assume that you know the basics of circles, including the area and circumference formulas for circles. If any of that is unclear to you, I would invite you to watch the necessary videos. So let me now define what cylinders are. Cylinders are formed from two congruent parallel bases, and these bases are themselves formed from closed curves. So imagine you had two parallel and congruent bases formed from closed curves, and then you made a three-dimensional shape by adding the rest of the surface to create that three-dimensional shape. So that is an example of a cylinder. All right? A common type of cylinder is one formed from closed curves that form circles. So there is an example of a circular cylinder, and the parallel congruent bases don't have to be lined up vertically. So a circular cylinder can also look like this last example on the right. Okay? Now, if the two parallel congruent bases are lined up vertically so that all the corresponding points on each of the bases are above or below each other, then that's called a right cylinder. If the bases are circles, it's a right circular cylinder. Okay? So the first example that I drew, that is a cylinder. The last example is a circular cylinder, and the middle example is a right circular cylinder. Okay? Now, the first example, if the bases are lined up and they look like they're lined up, then that if they were lined up, that would also be considered a right cylinder. Now I'd like to discuss the volume of cylinders. So I will focus on right circular cylinders because they're the most common. So let me draw an example of a right circular cylinder. And the area of a circle is equal to pi times the square of the radius. And that gives the number of a standard sized square, the number of those standard sized squares that you would need to form a two-dimensional figure with an equivalent area. It's also the number of cubes you would need, standard size cubes, to such that it would it would cover the base of a cylinder. And then If you multiply that number of cubes that can cover the base by the height, that'll give you the number of standard size cubes to create a three-dimensional figure with the equivalent volume. So all of that is to say that the formula for the volume of a right circular cylinder is the area of the base times the height. And the area of the base, the area of the circle, is pi r squared, where the radius is r, times h if the height is h. All right, so let me label my picture. So I'm assuming that I've denoted the height of this right circular cylinder by h and the radius by r. All right, so give me a minute to finish labeling my picture with those variables. All right, so there is the volume formula. Now, what about the formula for the surface area? So clearly, we're going to have to include the areas of the two bases, the two circles. What about the rest of the surface? Now, imagine that you had a hollow cylinder, so you removed the bases, and let's say it was made of cardboard, and let's cut the cylinder, the cardboard cylinder, like where that green line segment is. Now, suppose you try to flatten that part of the surface of the cylinder onto a table. Would you agree that if you flattened it out, you'd have a rectangle? Okay, we even know what the dimensions of the rectangle are. So one of the dimensions will be the height of the cylinder, and the other dimension will be the circumference of the circle, the 2 pi r in this case, when you unravel that cardboard. All right, so all of that is to say that we can find the rest of the area, the rest of the surface area, by finding the area of this rectangle. So putting it all together, the surface area of a cylinder is 2 pi r squared, that takes care of the two bases, plus 2 pi r h. All right. Now let's use these formulas in some examples. So give me a minute to make a picture. Suppose I had a right circular cylinder where the height was 10 meters and the radius was 2 meters. Can we find the volume and surface area? So for the volume, I would use pi times 2 squared times the height, and that would give 40 pi cubic meters. And for the surface area, I would use 2 times pi times 2 squared plus 2 pi times 2 times 10, and that's equal to, let's see, 8 pi plus 40 pi, which gives 48 pi square meters. All right. Now, I would like you to do an example. So give me a minute to make a picture. Suppose you had a metal container in the shape of a right circular cylinder that was used for holding water, and you wanted to know the volume of water that that cylindrical container could hold, and you also wanted to know the surface area. So if the height of the cylinder was 4 meters and the diameter was 10 meters, could you use that information to do the following? Find the volume and surface area of the cylinder. So pause the video if you like and try to do that now. All right, so I'll go ahead and work it out as well. For the volume, pi r squared times h, pi times the radius squared times the height, in other words. So pi times 10 divided by 2 squared times 4, because 10 is not the radius. So that gives 100 pi cubic meters for the volume. And then for the surface area, I will use the surface area formula. 2 times pi times the square of the radius of the base plus 2 times pi times the radius times the height. So let's see, 50 pi plus 40 pi equals 90 pi square meters for the surface area. All right. Now I'd like you to try one more example. A cylinder and a cone have the same base areas. What is the ratio of their heights if they also have the same volume? And you can assume that the cylinder is a right circular cylinder. Okay? So pause the video and try to work that one out, please. Okay, so I'll go ahead and work it out as well. So let me make a picture. So I'll draw a cylinder, and I'll draw a cone with the same base, and the height, you might guess that the height has to be greater than the height of the cylinder because there's not much volume near the vertex of the cone, right? And let's give some names to various dimensions. So if the areas of the bases are the same, then they both have the circles, all the circles have the same radii. And let's call the height of the cone A and the height of the cylinder B. So give me a minute to label my picture. Alright, so they have the same base areas, so that means they have the same radius, the r, in the picture. What's the ratio of their heights if they also have the same volume? So let's set the volumes equal. 1/3 pi r squared times a is equal to pi r squared times b. And the pi's cancel, the r squareds cancel, and so we're left with 1/3 a equals b. So that means that a over b is equal to 3. So all of that is to say that if you want to build a cone on the same circle as a cylinder, as the circle in a cylinder, you have to make the height 3 times bigger than the height of the